Back in 2014, the Hubble Space Telescope captured something astonishing on Europa, one of Jupiter's biggest moons, a massive geyser-like plume that appeared to spurt from the moon's icy crust. The liquid seemed to vent into the moon's atmosphere, reaching 62 miles into space. 2 years later, researchers spotted another suspected plume in the same 200-mile-wide hotspot, reaching almost 120 miles into space. Detecting the purported plumes on Europa, however, approaches the limits of what Hubble can do, which caused some researchers to cast doubt on the plume's existence. But now, as Sarah Kaplan reports for The Washington Post, a new study reviewing 20-year-old data from the Galileo spacecraft's flybys of Europa adds to the mounting evidence that the plumes are indeed real. While geysers spurting into space are cool on their own, it's an especially big deal if they exist on Europa. According to a press release from NASA, Europa harbors a salty ocean twice the size of Earth's under its frozen crust, making it one of the solar system's prime candidates for harboring some sort of life. The problem is, landing a spacecraft on Europa and drilling through the mile or more of ice on its surface is an expensive and technologically challenging feat. But if Europa is venting the contents of its ocean or subsurface lakes into space, researchers may be able to study the plumes to search for organic molecules. They may even be able to detect extraterrestrial bacteria lurking in the waters, but only if the plumes exist. To figure out the puzzle, Melissa A. McGrath, a senior scientist at the SETI Institute, turned to data from the Galileo mission, reports Kenneth Chang at The New York Times. During this trip, the spacecraft swung by Europa 11 times, conducting radio experiments that hint of an atmosphere. The data also suggest the craft flew through a dense region of particles, something McGrath thought might come from Galileo flying through a watery plume. The find drew interest from other researchers who also looked into the numbers. What they found is that magnetometer readings and radio signals also showed anomalies when the craft flew over the area of the purported plumes determined by Hubble. We saw very peculiar changes in the magnetic signal, something I don't think has been explained in the past, team member Jay Gia from the University of Michigan tells Nadia Drake at National Geographic. We also pulled out the plasma wave data from Galileo, and surprisingly, around the same time, the plasma wave showed anomalous emissions. So when you put those two together, that indicated that something very special had happened during that interval. As Kaplan reports, the team ran the data through a complex modeling system of Europa's plumes. The readings were spot on for what would be expected if Galileo had flown through a salty plume. The research appears in the journal Nature Astronomy. So why did the Galileo team miss the data during the initial flyby in 1997? As Gia tells Mike Wall at Space.com, the team wasn't specifically looking for plumes back then. They also didn't have the computing power to analyze the numbers. To make sense of the observations, we had to really go for sophisticated numerical modeling, and I don't think those were available back 20 years ago, he says. The find has big implications for the Europa Clipper, a probe currently under development by NASA and expected to launch in the early 2020s. The craft will use ice-penetrating radar to peer under Europa's shell and will make 45 flybys of the Moon, getting as close as 16 miles. Robert T. Papalardo, mission scientist for the Clipper, tells Chang it may be possible to reroute the Clipper to pass over the purported plume. But even if the Clipper does grab some interesting molecules, it likely won't be a direct confirmation of life. It's unlikely that one of these plumes is going to throw a fish into space that's going to whack into Europa Clipper. Cynthia Phillips of NASA's Jet Propulsion Laboratory tells Drake, it's more likely to come from pockets of liquid that are closer to the surface. So, not free ocean samples, but free subsurface samples. Like this article? Sign up for our news